Imagine looking up at the night sky filled with uncountable stars and realizing that each one might hold a planet teeming with life. Could it be possible that out there, among the billions of galaxies, we are not alone? For centuries, humanity has pondered this question, but today, advancements in space exploration and technology bring us closer than ever to finding an answer. Scientists have uncovered extraordinary planets beyond our solar system, worlds that might be capable of hosting life as we know it, or even life beyond our imaginations. In this video, we're diving into the fascinating discoveries of the universe to reveal the top 20 planets and moons that could potentially harbor alien life. From distant exoplanets with Earth-like characteristics to the mysterious moons of our own solar system, prepare to journey across the cosmos as we uncover the secrets of these incredible worlds. Are you ready to explore the possibilities and mysteries that lie beyond our world? Stay with us as each discovery brings us one step closer to understanding our place in the universe. Now turning to our first remarkable discovery, Kepler 452b, often referred to as Earth's cousin. This fascinating exoplanet sits comfortably in what scientists call the Goldilocks Zone, the perfect distance from its star where conditions might allow liquid water to exist, a key ingredient for life as we understand it. What makes Kepler 452b even more intriguing is its striking similarity to Earth. Orbiting a star much like our Sun, this planet completes one orbit in roughly 385 days, remarkably close to an Earth year. With a diameter about 60% larger than our own planet, Kepler 452b falls into the category of super-Earths, meaning it has the potential for a rocky surface that could support life. Research suggests that it enjoys a stable climate and receives slightly more energy from its star compared to Earth, fostering the possibility of mild, Earth-like temperatures. This combination of factors positions Kepler 452b as a strong candidate for alien life, raising the tantalizing question, could this distant world host an ecosystem, or perhaps even intelligent life forms? While its exact atmospheric composition remains a mystery, Kepler 452b's Earth-like characteristics make it a subject of intense scientific interest and a hopeful step towards discovering life beyond our planet. Now turning to the atmosphere and climate of Kepler 452b, scientists are captivated by what this exoplanet might reveal about its ability to support life. While direct measurements of its atmosphere remain beyond our current technology, researchers speculate that its size and location in the Goldilocks Zone could allow for the existence of a thick, protective atmosphere. Such an atmosphere might not only shield the planet from harmful radiation, but also trap just enough heat to create a stable, life-supporting climate. If Kepler 452b does possess an Earth-like climate, it could mean mild temperatures with the potential for liquid water to persist on its surface, a critical ingredient for life as we know it. Additionally, its slightly higher energy intake from its star might even spark more dynamic weather patterns, possibly fostering rich, diverse ecosystems. Findings from the Kepler mission have emphasized the potential for planets like Kepler 452b to harbor conditions suitable for life, reigniting the search for biosignatures, chemical traces that could indicate biological activity. Beyond its tantalizing similarities to Earth, the challenges of studying such a distant planet leave much to the imagination, fueling hope and curiosity. Could its skies hold clouds of water vapor? Could its surface feature lakes or oceans teeming with primitive life? These questions remain unanswered, but they propel us forward in our quest to explore the possibility of life beyond our solar system. Moving forward, let us dive into Proxima Centauri b, an equally fascinating exoplanet and the closest known candidate for hosting alien life. Moving forward, we arrive at Proxima Centauri b, a truly remarkable exoplanet and the closest known planet outside our solar system that resides in its star's habitable zone. Orbiting the cool, red star Proxima Centauri, which is part of the Alpha Centauri system, Proxima Centauri b sits at a distance of just over 4 light-years from Earth. This proximity makes it a significant milestone in our quest to find potentially habitable worlds, as it is within reach of future advanced exploration technologies. The planet's location in the habitable zone means it orbits at just the right distance from its star to allow for the possibility of liquid water, a crucial factor for life as we understand it. What makes Proxima Centauri be particularly intriguing is its Earth-like size and mass, indicating that it could possess a rocky surface rather than a gaseous composition. If this is the case, it enhances the chances of it having conditions that might support some form of life. In addition to its promising location and characteristics, its closeness to Earth opens up the possibility of studying it in much greater detail in the near future. Efforts like the Breakthrough Starshot initiative aim to send tiny, high-speed spacecraft to explore Proxima Centauri b, potentially providing the first glimpse of another world where life could exist. The excitement surrounding this exoplanet stems not just from its potential for habitability, but also from the opportunities it presents for advancing our understanding of the universe and our place within it. As we delve deeper into what Proxima Centauri b may offer, it invites us to consider how close we might be to uncovering one of the greatest mysteries of our time, whether we are truly alone in this vast cosmic expanse. Let us now examine the challenges that this fascinating planet faces in sustaining life, as we look into the potential effects of radiation and other factors on its habitability. Now turning to the challenges Proxima Centauri b faces in sustaining life, one of the most significant hurdles lies in the intense radiation emitted by its host star. Proxima Centauri, being a red dwarf, is known for its stellar flares, sudden bursts of radiation that could potentially strip away a planet's atmosphere over time. Without a protective magnetic field or a thick atmosphere, this radiation could make the surface of Proxima Centauri b inhospitable for life as we know it. However, scientists remain divided on the extent of this threat. Some argue that if Proxima Centauri b has a sufficiently dense atmosphere or a robust magnetic field, it might still be capable of shielding the surface from harmful radiation. Others speculate that even if surface conditions are challenging, life could potentially exist below ground or in subsurface oceans, far from the reach of the star's extreme flares. Research into this exoplanet's atmosphere is ongoing, with scientists striving to determine whether it has retained enough of its atmospheric layers to support life. Tools like the James Webb Space Telescope and other advanced observation instruments play a crucial role in this investigation, offering glimpses into the atmospheric composition and surface conditions of distant planets like Proxima Centauri b. These studies are essential in bridging the gap between what we hypothesize and what we can confirm. The scientific community continues to explore these possibilities with a mix of caution and optimism, recognizing that while the challenges are immense, the potential rewards of discovering life on Proxima Centauri b are equally profound. As we turn our gaze to the next celestial body on our journey, we encounter the intriguing TRAPPIST-1e, a rocky planet within a system that holds its own unique promise for uncovering alien life. Moving forward, we arrive at TRAPPIST-1e, a rocky exoplanet nestled within the fascinating TRAPPIST-1 system, located about 39 light-years away from Earth. What makes TRAPPIST-1e so captivating in the search for alien life is its position comfortably within the habitable zone of its ultra-cool red dwarf star. This means it lies at just the right distance for liquid water to potentially exist on its surface, a critical factor for supporting life as we understand it. TRAPPIST-1e is relatively Earth-sized, with a diameter and mass strikingly similar to our planet, further enhancing its potential to harbor life. Its surface temperature is estimated to allow water to remain in a liquid state if the atmospheric conditions are just right. Scientists believe that its rocky composition is another promising feature, as rocky planets with stable surfaces are more likely to support complex geological and atmospheric processes necessary for sustaining life. Furthermore, the TRAPPIST-1 system itself is unique, hosting a remarkable 7 exoplanets, several of which are also located within the habitable zone. This density of planets in a single system offers an extraordinary opportunity to compare and study their individual capabilities for hosting life. TRAPPIST-1e stands out among them as one of the most promising candidates, and ongoing observations aim to uncover more about its atmosphere, surface conditions, and potential habitability. With this level of Earth-like characteristics and its position within the habitable zone, TRAPPIST-1e continues to be a target of high interest for astronomers and astrobiologists alike. Now turning to the next planet in this remarkable system, TRAPPIST-1f offers yet another glimpse into the possibilities for life beyond our world, showcasing the unique diversity of this extraordinary star system. Now turning to TRAPPIST-1f, we explore another fascinating world within the captivating TRAPPIST-1 system. Like its neighbor TRAPPIST-1e, this exoplanet resides within the habitable zone of its ultra-cool red dwarf star, meaning it orbits at a distance where conditions might permit liquid water to exist on its surface. What sets TRAPPIST-1f apart is its slightly cooler environment, which could result in unique atmospheric or surface features that differentiate it from TRAPPIST-1e. This diversity adds to the excitement of studying multiple planets within the same system, as each offers a new window into potential habitability. TRAPPIST-1f is similar in size to Earth, marking it as another rocky planet that could support stable surfaces essential for life to thrive. The idea of having several planets in one star system, all with potential to host life, is truly extraordinary. It raises fascinating questions about whether life, if it exists, could independently evolve on multiple planets within such close proximity. Imagine an interplanetary ecosystem where microbial or even complex life forms could potentially interact across these worlds. Researchers are particularly intrigued by the atmospheric composition of TRAPPIST-1f and whether conditions might support greenhouse gases that could regulate the planet's temperature, keeping it within a range suitable for life. The synchronized orbits of the TRAPPIST-1 planets also create a unique dynamic, as their gravitational influences on each other could impact their climates and geological activity. TRAPPIST-1f stands as a perfect example of why the TRAPPIST-1 system is a treasure trove for studying the building blocks of life beyond Earth. As scientists continue to observe and analyze these planets, TRAPPIST-1f remains a key player in our search for habitable worlds, reinforcing the hope that alien life might exist just a little closer to home. As we move beyond TRAPPIST-1f, the broader implications of this remarkable star system continue to spark curiosity, showcasing the value of studying such a dense collection of promising exoplanets. With the next phase of the journey in sight, we now examine the TRAPPIST-1 system as a whole, a cosmic marvel offering unparalleled opportunities to study the potential for alien life. Imagine a single star hosting not one, but 7 rocky planets, of which at least 3 reside in the coveted habitable zone. This extraordinary setup makes the TRAPPIST-1 system a unique laboratory for exploring how life could emerge and evolve under varying conditions within the same stellar neighborhood. The proximity of these planets to one another is astonishing, with distances so close that a person standing on one surface might even see the neighboring planets as larger than our own moon appears from Earth. This level of closeness sparks intriguing possibilities, including the exchange of material between planets through meteorite impacts, potentially sharing early building blocks of life across multiple worlds. Such a phenomenon, known as panspermia, fuels speculation about whether life could originate on one planet and spread to others within the system. Another captivating aspect of TRAPPIST-1 is the synchronized orbital dance of its planets, where each orbits in a near-resonant pattern, creating gravitational interactions that may influence their climates, geological activity, and even atmospheric conditions. These interconnected dynamics provide a rare chance to understand how planetary systems develop and sustain environments that could support life. If the TRAPPIST-1 planets reveal distinct atmospheres, surface compositions, or climates, it may offer critical insights into the diversity of habitable worlds and how life-friendly conditions might arise under different circumstances. The potential for interplanetary ecosystems within a single star system reshapes our understanding of habitability on a cosmic scale, suggesting that life, if it exists, might thrive not just on individual planets but within networks of closely linked worlds. This makes the TRAPPIST-1 system an unprecedented target for future observations and missions. Scientists believe that studying this dense collection of Earth-like planets could unlock answers to some of humanity's most profound questions about our place in the universe. Moving forward, the TRAPPIST-1 system stands as a shining example of the wonders that await us as we continue to survey the cosmos, searching for signs of life beyond the confines of our own pale blue dot. Now turning to LHS 1140b, this fascinating exoplanet has captured the imagination of scientists as one of the most promising candidates for alien life. Located in the habitable zone of a calm, long-lived red dwarf star, LHS 1140b offers a stable environment where life could potentially arise and thrive. This planet, classified as a super-Earth due to its larger mass and size compared to our planet, boasts a rocky surface that could support the presence of liquid water, an essential ingredient for life as we know it. Perhaps even more remarkable is the evidence suggesting a dense atmosphere encasing LHS 1140b, which could protect the planet's surface from harmful radiation while creating a temperate climate conducive to sustaining life. Its star, notable for its relative inactivity compared to other red dwarfs, ensures that the planet is not subjected to extreme stellar flares or radiation, which can strip away atmospheres and make conditions hostile for life. This stability is a critical factor that makes LHS 1140b stand out in the ongoing search for habitable worlds. Scientists are particularly excited about the potential for future observations using advanced telescopes, which could analyze the atmospheric composition of this world to search for biosignatures such as oxygen, methane, or other gases associated with living organisms. If such markers are detected, it could signify the presence of biological processes occurring on the planet, further elevating its status in the quest to find life beyond Earth. Moreover, the compact size and brightness of its host star make LHS 1140b an ideal target for atmospheric studies, as its transits across the star allow researchers to gather detailed data about its chemical makeup. This combination of features a rocky surface, dense atmosphere, and a stable, nurturing star positions LHS 1140b as a beacon of possibility, reminding us that life might flourish in places far beyond our current understanding. As we delve deeper into the mysteries of our universe, LHS 1140b serves as a prime example of worlds that could redefine our knowledge of habitability and open the door to discovering life among the stars. Moving forward to Gliese 667cc, this extraordinary exoplanet continues to fuel our fascination with the possibility of alien life. Classified as a super-Earth, Gliese 667cc is located in the habitable zone of its parent star, where conditions are just right for liquid water to potentially exist, a hallmark for life as we understand it. What sets this world apart is its position within a remarkable triple-star system, a feature that could create intriguing dynamics for any life forms that might evolve there. Orbiting a red dwarf star, Gliese 667cc benefits from the relatively stable and long-lasting energy output of this type of stellar host, offering a consistent environment over vast timescales. Scientists are captivated by the idea that the gravitational interplay of three stars could influence this planet's orbital path and, by extension, its climate and habitability. Furthermore, its slightly larger mass compared to Earth could allow it to retain a thicker atmosphere, which might be capable of shielding its surface from harmful cosmic rays while creating conditions favorable for life. The presence of liquid water remains a tantalizing prospect, as this is a critical ingredient in biochemical processes. Researchers are optimistic that upcoming observations could reveal even more about the atmospheric composition of Gliese 667cc, potentially identifying gases linked to biological activity such as carbon dioxide, oxygen, or methane. The complex interplay of its unique triple star surroundings and its intrinsic characteristics makes Gliese 667cc an exceptional candidate in the ongoing search for life beyond Earth. This planet reminds us that nature often surpasses our expectations, crafting environments that challenge and expand our understanding of where life can take root. Now turning to K2-18b, this fascinating exoplanet has captured the attention of scientists and space enthusiasts alike for a groundbreaking discovery: water vapor detected in its atmosphere. This is an extraordinary finding because water is one of the fundamental building blocks for life as we know it. What makes K2-18b even more intriguing is its location in the habitable zone of its parent star, a region where conditions could allow liquid water to exist on its surface or within its layers. This planet is classified as a super-Earth due to its size, which is more than twice the diameter of Earth and 8 times its mass. Its substantial composition suggests a dense atmosphere that could create a stable environment, potentially shielding the planet from harmful radiation and fostering conditions conducive to life. The discovery of water vapor here is a game-changer, as it opens up possibilities for microbial or even more complex life forms to thrive. While its surface conditions remain a topic of intense study, the combination of its size, atmospheric composition, and favorable position in the habitable zone makes K2-18b one of the most promising candidates in the search for extraterrestrial life. Moving forward, let us dive deeper into the significance of the water vapor detected on K2-18b and why it has generated such excitement in the scientific community. Water vapor in the atmosphere of an exoplanet is not just a trivial finding, it is a monumental clue in the puzzle of alien life. Scientists suggest that the presence of water vapor could indicate active water cycles on the planet. This means processes such as evaporation and condensation might be occurring, similar to what we observe here on Earth. These cycles play a critical role in maintaining a stable climate, which is essential for sustaining life. Moreover, this discovery raises possibilities about the existence of liquid water, either on the planet's surface or below its thick, dense atmosphere. Liquid water is considered a universal solvent capable of supporting chemical reactions necessary for life. While no direct evidence of life has yet been found, these observations lead to exciting theories about what could potentially exist beneath the planet's gaseous exterior. Microbial life, similar to extremophiles on Earth that thrive in harsh environments, could find a home here. Some researchers even ponder the possibility of more complex organisms adapting to the unique conditions of this super-Earth. K2-18b's atmosphere, rich in hydrogen and other molecules, might create a greenhouse effect that stabilizes temperatures, further bolstering its habitability. However, much remains unknown, and ongoing research is crucial to unraveling the mysteries of this planet. As scientists refine their techniques and technology advances, K2-18b stands as a cosmic beacon, urging us to look deeper into the universe's endless possibilities for life. Now turning to our next destination in the cosmos, HD 40307G emerges as a fascinating candidate in the search for alien life. Often referred to as a super-Earth, HD 40307G earns this title due to its size and mass, which are significantly larger than Earth yet smaller than the gas giants within our solar system. What makes this planet particularly intriguing is its stable orbit within its star's habitable zone, the region where conditions might allow for the presence of liquid water. Stability in orbit is no minor detail. It ensures that the planet experiences consistent energy from its star, creating an environment where temperatures could remain steady over long periods. This is a crucial factor when considering the potential for life, as erratic or extreme conditions can be hostile to its development. Scientists suggest that HD 40307G's surface might support liquid water, a key ingredient for life as we understand it. The planet's mass also increases the odds of it having a thick atmosphere, which could help retain heat and shield the surface from harmful radiation. Though the exact composition of HD 40307G's atmosphere remains a mystery, researchers theorize that it could host a climate capable of supporting some form of life. Imagine a world with vast oceans or even subterranean water reservoirs, serving as cradles for potential microbial ecosystems. While it is still far from confirmed, the mere possibility fuels excitement and continued investigation. HD 40307G stands as a remarkable reminder of how diverse and potentially life-supporting exoplanets can be. But as we marvel at its potential, we must also look further, as there are even more intriguing worlds waiting to be explored in our cosmic journey. Moving forward, ROS 128b captures our attention as an exceptional nearby exoplanet with tantalizing potential for hosting alien life. Situated just 11 light-years away from Earth, this planet resides in the habitable zone of its parent star, ROS 128, a red dwarf star known for its stability. This stability is crucial because it suggests the planet could avoid the harsh solar flares often associated with red dwarfs, providing a calmer environment for life to potentially thrive. ROS 128b is often compared to Earth due to its similar size and temperature range, which places it among the most promising Earth-like candidates discovered so far. Researchers are especially intrigued by the possibility that its surface could harbor liquid water, a fundamental ingredient for life as we understand it. What adds further excitement is the proximity of ROS 128b, which makes it a prime target for detailed study using current and future observation technologies. While we have yet to determine the exact composition of its atmosphere, scientists speculate it could contain the necessary elements to support life. If ROS 128b indeed has a stable climate and the right atmospheric conditions, it could serve as a significant milestone in our understanding of habitability beyond Earth. These possibilities drive ongoing research and spur the imagination, as each discovery brings us closer to answering the question of whether we are truly alone in the universe. And as we set our sights on the cosmos, ROS 128b becomes an inspiring reminder of how rich and varied the universe is in its potential for life. Now, let us venture further to explore even more extraordinary worlds that may hold the key to unlocking this age-old mystery. Now turning to Tau Ceti e, this fascinating exoplanet orbits within the habitable zone of Tau Ceti, a star located just 12 light-years away from Earth. What sets Tau Ceti e apart is its striking Earth-like qualities, including a similar size and rocky composition, sparking intrigue about its potential to host life. Its location in the habitable zone suggests the possibility of liquid water on its surface, a key ingredient for life as we know it. Moreover, Tau Ceti, a stable and long-lived star, provides an environment relatively free from the disruptive solar flares often associated with less stable stars, further enhancing the planet's candidacy for habitability. However, scientists have noted some challenges that could impact its life-hosting potential. Tau Ceti e receives a higher level of solar flux compared to Earth, which may result in a hotter environment that could affect its ability to sustain liquid water and a stable climate. While the exact details of its atmosphere remain unknown, researchers speculate about whether it contains compounds like carbon dioxide or water vapor, which are critical for regulating temperature and potentially supporting life. Despite these uncertainties, the sheer proximity of Tau Ceti e makes it an alluring target for future exploration. Advanced telescopes and observational tools hold the promise of unveiling more about its atmosphere, surface conditions, and overall habitability. As one of the closest Earth-like planets discovered, Tau Ceti e fuels our excitement about the search for alien life, offering a glimpse into the types of worlds that could someday redefine our understanding of life in the universe. With this intriguing candidate explored, let us continue our journey as we uncover even more extraordinary possibilities among the stars. Now turning to Wolf 1061c, this captivating rocky exoplanet lies just 14 light-years away from Earth, making it one of the closest potentially habitable planets to our solar system. Its proximity not only excites scientists but also raises the prospect of more in-depth exploration in the near future. What makes Wolf 1061c particularly intriguing is its position within the habitable zone of its star, Wolf 1061, a red dwarf known for its stability. This positioning hints at the possibility of liquid water on its surface, an essential ingredient for life as we understand it. Moreover, its rocky composition and size, which is slightly larger than Earth, add to its appeal as a candidate for habitability. Unlike planets orbiting more volatile stars, Wolf 1061c benefits from its host star's lower levels of solar activity, reducing the likelihood of harmful radiation disrupting any potential life-supporting environment. However, scientists acknowledge certain challenges when it comes to Wolf 1061c's capacity to harbor life. One such challenge is its tight orbit around its star, which could lead to tidal locking, a phenomenon where one side of the planet always faces the star while the other remains in perpetual darkness. This stark division between day and night might create extreme temperature variations, potentially complicating the development of stable climates. Despite these uncertainties, Wolf 1061c remains a compelling subject of study, offering valuable insights into the diverse conditions under which alien life might exist. Future observational efforts and technological advancements in studying exoplanetary atmospheres are expected to further illuminate whether this nearby world could indeed be a cradle for life. As we continue delving into the mysteries of our universe, Wolf 1061c serves as a fascinating reminder of how much remains to be discovered just beyond our cosmic backyard. Let us now venture onward to uncover yet another extraordinary candidate in our search for extraterrestrial possibilities. Moving forward to GJ 3470b, we encounter a smaller Neptune-like planet that presents a unique opportunity in the quest for extraterrestrial life. Located over 100 light-years from Earth, this fascinating world has drawn attention primarily due to its dense atmosphere, which offers a potential haven for alien life forms. Unlike rocky planets, GJ 3470b's gaseous composition sparks curiosity about the possibility of life existing not on its surface, but within the layers of its thick atmosphere. Recent studies have revealed traces of water vapor in its atmosphere, a key indicator that conditions might support life. Scientists hypothesize that the temperature and pressure within certain atmospheric layers of GJ 3470b could create a so-called habitable zone where microbial life forms might find refuge. This speculative environment, while vastly different from Earth's, opens up exciting questions about the diversity of life-supporting conditions in the universe. Adding to its intrigue, GJ 3470b's relatively close proximity to Earth makes it a prime candidate for detailed atmospheric analysis, allowing researchers to better understand its chemical composition and thermal profile. While challenges do exist, such as its host star's tendency for occasional flare activity that could disrupt its atmospheric stability, the ongoing advancements in telescopic and observational technology provide hope for overcoming these limitations. GJ 3470b reminds us that the search for alien life may uncover entirely new kinds of habitats, ones that challenge our Earth-centric perspectives on what makes a planet, or in this case, a planetary atmosphere capable of hosting life. With such thrilling prospects in mind, let us journey onward to yet another celestial candidate that adds its own unique puzzle piece to the search for life beyond Earth. Now turning to WASP-12b, we explore an extraordinary world that challenges conventional ideas of habitability. Situated approximately 800 light-years from Earth, this exoplanet has captured the imagination of scientists due to its thick, carbon-rich atmosphere. Unlike the Earth-like conditions we often associate with the potential for life, WASP-12b's environment is strikingly exotic, leading researchers to speculate about entirely different forms of life that could adapt to such extremes. Its atmosphere is laden with hydrogen, helium, and traces of carbon molecules, including methane, which are crucial building blocks for organic chemistry. These components raise intriguing possibilities about whether life could arise under such unconventional circumstances. Adding to its uniqueness, WASP-12b is an extremely hot gas giant, orbiting dangerously close to its host star. This proximity subjects it to intense radiation, creating a dynamic and volatile atmospheric environment. While such factors seem inhospitable at first glance, some scientists hypothesize that life might exist in pockets of the atmosphere where conditions are more stable and less extreme. These hypothetical refuges could resemble the high-altitude microbial habitats found in Earth's own upper atmosphere, albeit adapted to an entirely different chemical and thermal landscape. Additionally, WASP-12b's rapid orbit, completing a revolution around its star in just over one Earth day, offers a unique opportunity for continuous observation, allowing researchers to gather extensive data on its atmospheric behavior. Despite the challenges, its chemical diversity inspires groundbreaking questions about what types of biochemistry could emerge under such alien conditions. As humanity continues to unlock the mysteries of planets like WASP-12b, we are reminded that the universe may hold forms of life that defy our expectations, expanding the boundaries of what we consider possible. Moving forward, let us shift our attention to a planet that brings us back to the search for more familiar hallmarks of habitability while holding its own fascinating secrets. Now turning to Kepler-22b, we arrive at an exoplanet that has garnered significant attention for its remarkable similarities to Earth. Located 600 light-years away in the constellation of Cygnus, Kepler-22b was one of the earliest discoveries to ignite hopes of finding alien life beyond our solar system. The planet's position in the habitable zone of its host star, a region where temperatures could allow liquid water to exist, makes it a prime candidate for supporting life as we know it. What sets Kepler-22b apart is its size, which is approximately 2.5 times the radius of Earth. This categorizes it as a super-Earth, a type of planet that may possess a rocky surface or a substantial oceanic environment. Scientists speculate that if Kepler-22b has a dense atmosphere, it could trap heat effectively, creating conditions suitable for a stable water cycle and potentially fostering life. Adding to its allure is Kepler-22b's orbit around a Sun-like star, which provides consistent energy levels similar to what our Earth receives. This trait has led researchers to consider the possibility of Earth-like climates existing on its surface. While the exact composition of Kepler-22b's atmosphere remains unknown, models suggest it could contain a mix of gases capable of supporting biological processes. Its orbital period of 290 days closely mirrors Earth's 365-day cycle, further enhancing its status as a familiar yet mysterious world. This planet's position on the edge of what scientists call the Goldilocks Zone offers an ideal balance, not too hot, not too cold, creating an environment that might be just right for sustaining life. The intrigue surrounding Kepler-22b lies in its potential to bridge the gap between the known and the unknown, offering a tantalizing glimpse into worlds that could mirror our own in unexpected ways. As we venture deeper into the cosmos, discoveries like Kepler-22b remind us of the vast potential for habitable planets and the endless possibilities they represent. Moving forward, let us explore a world that challenges traditional ideas of habitability while continuing to inspire wonder in the search for alien life. Now turning to GJ1214b, we encounter an extraordinary celestial body often referred to as a potential water world, situated approximately 48 light-years away in the constellation of Ophiuchus. GJ1214b has captivated scientists with its intriguing characteristics. This exoplanet is categorized as a mini Neptune due to its size, which is about 2.5 times the radius of Earth, and its substantial gaseous atmosphere. What makes GJ1214b particularly fascinating is the strong evidence pointing to the presence of water in unprecedented forms. Researchers believe that beneath its thick, hydrogen-rich atmosphere lies a vast ocean layer or even a planet entirely covered in water. This possibility places GJ1214b in an exceptional category among exoplanets, as an aquatic environment could serve as a cradle for life. Adding to this, the planet orbits a red dwarf star at a distance close enough to maintain temperatures that might support liquid water, though its climate is likely to be much warmer and more humid than Earth. The dense atmosphere of GJ1214b creates greenhouse-like conditions, potentially trapping heat and fostering an environment where complex chemical reactions could occur. These reactions may be essential for life, offering a dynamic setting for biological processes to take root. While scientists have yet to determine the exact composition of its atmosphere, studies hint at a high concentration of water vapor along with other molecules that could hint at prebiotic activity. The warm, steamy conditions suggest that exotic forms of life, vastly different from what we know, might adapt to thrive here. What elevates the intrigue of GJ1214b is its potential to redefine our understanding of habitability. Unlike planets with Earth-like conditions, this water world proposes entirely new scenarios for alien ecosystems. Could life exist in such an oceanic environment, hidden beneath endless clouds of vapor? The questions surrounding GJ1214b remind us that the search for alien life requires expanding our imaginations beyond familiar templates. With every breakthrough, this exoplanet continues to spark curiosity and push the boundaries of what we consider possible. Moving forward, let us turn our attention to another fascinating world, one that challenges our perceptions of chemistry and the life it might sustain. Now turning to Kepler-186f, we arrive at a groundbreaking discovery in the quest for alien life. Kepler-186f holds the distinction of being the first Earth-sized planet identified within the habitable zone of its star, a monumental find by the Kepler Space Telescope that has forever changed the way we approach the search for life beyond Earth. Located approximately 500 light-years away in the constellation of Cygnus, Kepler-186f orbits a red dwarf star, significantly smaller and cooler than our Sun. What sets this exoplanet apart is its size, which is nearly identical to Earth's, and its position within the Goldilocks Zone, where temperatures might allow for the existence of liquid water on its surface. These factors together create a compelling case for potential habitability, making Kepler-186f a cornerstone in the study of exoplanets. This planet's characteristics open up exciting possibilities for Earth-like conditions, a concept that has long captivated scientists and enthusiasts alike. Although the exact composition of its atmosphere remains unknown, researchers speculate that it could sustain conditions favorable for life as we understand it. The planet receives about 1/3 of the energy from its star that Earth gets from the Sun, suggesting that its surface temperatures could range from cool to moderate, depending on the presence of greenhouse gases. If an atmosphere is present and dense enough, it might regulate temperatures and protect the planet from harmful stellar radiation, enabling the development of a stable environment where biological processes could flourish. The planet's Earth-sized dimensions also imply that it may have a gravity similar to our own, a vital factor for retaining an atmosphere and sustaining complex ecosystems. Kepler-186f's discovery represents a significant step forward in the search for habitable worlds, as it challenges the notion that life-friendly conditions are unique to planets orbiting stars similar to our Sun. The brightness and stability of its host star, though much dimmer, could provide a consistent energy source, fostering an environment where life might emerge and adapt. This opens the door to a broader understanding of what makes a planet suitable for life, suggesting that the diversity of potential habitats in the universe might be far greater than previously imagined. As we continue to study Kepler-186f, it inspires a profound sense of wonder about the kinds of ecosystems that might exist there and offers a tantalizing clue in our endless journey to answer the age-old question, are we truly alone? Moving forward, let us dive into another extraordinary celestial body, one whose chemistry stretches the boundaries of what we consider essential for life. Now shifting our focus to 55 Cancri F, we explore a planet that pushes the boundaries of possibility in our search for life beyond Earth. Located approximately 41 light-years away in the Cancer constellation, this exoplanet resides in a fascinating multi-planetary system anchored by its host star, 55 Cancri, a yellow dwarf similar to our Sun. What makes 55 Cancri F especially intriguing is its position within the habitable zone, a region where temperatures could allow liquid water to exist, a critical factor when assessing a planet's potential for hosting life as we know it. This celestial body is classified as a gas giant, much like Neptune in our own solar system, and while its gaseous nature might not make it directly habitable, it opens up exciting possibilities for its moons, which could harbor conditions suitable for life. Moons orbiting around gas giants are often heated by tidal forces, which could create subsurface oceans or maintain temperate environments, as we see with some of Jupiter's and Saturn's moons. Scientists theorize that if 55 Cancri F has a similar system of sizable moons, these could serve as thriving habitats for microbial or even more complex life forms, sustained by both the warmth of tidal heating and the energy radiating from the planet's host star. Adding to its allure, 55 Cancri F is part of a densely packed planetary system with a complex gravitational interplay, which might create unique environmental conditions. The planet completes its orbit in about 260 days, placing it within a comfortable range that balances proximity to its star for energy while avoiding the intense radiation found closer to such celestial objects. Moreover, its parent star, 55 Cancri, is known for its remarkable stability, a key quality that provides consistent energy over time, which is crucial for fostering the chemical building blocks of life. While much about 55 Cancri F remains shrouded in mystery, its location in the habitable zone combined with the potential for moon-hosted ecosystems makes it a compelling target for deeper exploration. This enigmatic planet invites us to consider the extraordinary variety of ways life could emerge and thrive, even in settings vastly different from Earth. As our technology advances, future missions may unlock the secrets of this distant world, further expanding the horizons of where and how we might find life in the cosmos. With this captivating planet in mind, let us turn our attention to a world within our very own solar system, one that continues to captivate scientists and dreamers alike with its icy exterior and hidden potential deep below. Now turning to Europa, a fascinating moon orbiting Jupiter that has emerged as one of the most promising places to search for alien life within our own solar system. Beneath its icy crust lies a vast subsurface ocean, hidden from view yet capturing the imagination of scientists for decades. This ocean, kept in a liquid state by the gravitational forces of Jupiter that generate heat through tidal flexing, is believed to contain more water than all the oceans on Earth combined. Where there is water, there is often the potential for life, making Europa an extraordinary focal point in the search for extraterrestrial ecosystems. Europa's surface is predominantly water ice, riddled with cracks and streaks that speak of geologic activity beneath. This dynamic nature hints at the possibility of hydrothermal vents at the ocean floor, similar to those found on Earth, where life thrives in complete darkness, fueled not by sunlight but by chemical energy. Such environments on our own planet host a stunning array of microbial and even multicellular life, suggesting that Europa's ocean may similarly harbor the conditions necessary for life to emerge and persist. Adding to its intrigue, Europa periodically ejects water vapor into space through plumes that breach its icy exterior, creating a potential opportunity for future spacecraft to analyze its composition without needing to drill through miles of ice. These geyser-like jets could provide direct clues about the ocean's makeup, including whether it contains organic molecules that are the building blocks of life. This makes Europa a prime candidate for upcoming missions, such as the Europa Clipper, which aims to study the Moon in unprecedented detail. What makes Europa particularly compelling is its resemblance to early Earth in terms of its potential for habitability. The combination of liquid water, chemical energy, and a dynamic environment aligns with what scientists consider key ingredients for life. While any life forms on Europa, if they exist, are likely to be microbial in nature, the discovery of even the simplest organisms would revolutionize our understanding of biology and the prevalence of life beyond our planet. Europa serves as a reminder that the search for alien life does not always require traveling to distant star systems. Right here in our cosmic backyard, this icy moon continues to inspire awe and curiosity, urging us to explore its hidden depths. As we marvel at Europa's potential, let us shift our gaze further into the outer reaches of the solar system to yet another icy world with a similarly tantalizing promise, the enigmatic moon of Saturn known as Enceladus. Now turning to Enceladus, one of Saturn's most mesmerizing moons, which has captured the attention of scientists as a leading contender in the search for extraterrestrial life. What sets Enceladus apart is its spectacular geysers that eject water vapor, ice particles, and organic compounds into space from cracks near its south pole, known as tiger stripes. These plumes are not just visually stunning but scientifically groundbreaking, offering direct evidence of a subsurface ocean beneath its icy crust. Much like Europa, Enceladus is kept warm by tidal forces exerted by Saturn, preventing its vast underground ocean from freezing solid. The material in these plumes has been analyzed by spacecraft like the Cassini mission, revealing tantalizing hints of organic compounds, the very building blocks of life. What makes this even more fascinating is the possibility of hydrothermal activity at the ocean floor, where heat and minerals could combine to create an environment conducive to life, much like the deep sea vents on Earth where thriving ecosystems exist without sunlight. Such conditions provide a compelling case for microbial life, or at the very least probiotic chemistry within Enceladus' hidden ocean. Additionally, these plumes provide a unique opportunity for exploration. Unlike Europa, which would require extensive drilling to access its subsurface ocean, Enceladus offers an open gateway to study its internal chemistry directly through the ejected material in space. Future missions could fly through the plumes, sampling their contents to analyze for signs of life. This accessibility makes Enceladus not only intriguing but also practical as a target for astrobiological research. Enceladus challenges the notion that life can only exist on planets within traditional habitable zones. Despite being far from the Sun, its subsurface ocean, organic chemistry, and geothermal energy create a trifecta of habitability factors that demand further investigation. If microbial life were discovered there, it would expand our understanding of where and how life can exist in the universe. As we uncover the secrets of this icy moon, Enceladus reminds us that even the coldest, most distant corners of our solar system may harbor the potential for life. With its plumes offering a direct window into an alien ocean, Enceladus invites us to look closer and dream bigger. Next, let us move to yet another celestial body of incredible intrigue, the enigmatic moon Titan, Saturn's largest satellite and a world with conditions unlike any other. Now turning to Titan, Saturn's largest moon and a celestial body that has captivated scientists with its extraordinary and alien features. Titan stands out as the only moon in our solar system with a dense atmosphere, which is primarily composed of nitrogen with traces of methane. This thick atmosphere not only supports a complex weather system but also allows for the formation of clouds, rain, and even rivers and lakes, though not of water as we know it. Instead, these liquid bodies are composed of methane and ethane, hydrocarbons that exist as liquids due to Titan's frigid surface temperatures. These lakes and rivers, along with vast, wind-sculpted dune landscapes, mirror processes we find on Earth, creating a fascinatingly Earth-like geography on an entirely alien world. What truly excites scientists about Titan is its potential for exotic forms of life. While its surface is far too cold for liquid water, some researchers speculate that life could exist within the liquid methane lakes or even beneath Titan's icy crust, where a subsurface ocean of liquid water might exist. This dual possibility makes Titan a unique target for astrobiological research. On the surface, any life would have to function in ways vastly different from life as we know it, perhaps using methane as a solvent instead of water. Meanwhile, in the hidden, warmer subsurface ocean, conditions might be more familiar, potentially supporting microbial life similar to what is hypothesized for moons like Europa and Enceladus. Another compelling feature of Titan is the organic chemistry occurring within its atmosphere. Sunlight interacting with methane creates complex organic molecules, some of which eventually rain down onto the surface. These organic compounds, combined with the potential for liquid environments, present a tantalizing resemblance to the early chemical processes that may have led to life on Earth. Titan's atmosphere and surface offer a natural laboratory for studying probiotic chemistry, helping scientists explore the conditions under which life might arise. The arrival of future missions, such as the planned Dragonfly rotorcraft mission, is expected to deepen our understanding of Titan's potential habitability. This innovative mission aims to survey Titan's surface directly, sampling its organic compounds and exploring its liquid methane lakes. By providing detailed data, it could offer groundbreaking insights into whether life, even in its most exotic forms, could survive and thrive in such an unearthly environment. Titan pushes the boundaries of our understanding of habitability, challenging the notion that life can only exist within Earth-like conditions. With its thick atmosphere, geological processes, and the possibility of not one but two different types of habitable environments, Titan inspires us to reimagine the possibilities for life in the universe. As we continue our search for answers, Titan reminds us that the universe holds surprises far beyond our expectations. Now, as we reflect on these 20 captivating worlds, let us bring together what we've uncovered and consider the profound implications of these discoveries. As we conclude this remarkable journey through the top 20 celestial candidates that might harbor alien life, we are left with a profound appreciation for the diversity and wonder of the universe. From exoplanets circling distant stars to moons within our very own solar system, each world presents unique possibilities and challenges. Some, like Kepler 452b and Proxima Centauri b, offer Earth-like similarities that spark the imagination, while others, such as Titan and Enceladus, stretch our understanding of what life could be, thriving in environments vastly different from our own. These discoveries push the boundaries of science and philosophy, encouraging us to rethink what it means to be habitable and to consider life in forms we can scarcely comprehend. The potential for subsurface oceans, alien atmospheres, and even exotic solvents like methane has expanded our search criteria and deepened our resolve to uncover the unknown. Each of these 20 worlds tells its own story, a story of conditions ripe with possibility, of challenges that inspire ingenuity, and of mysteries that beg to be solved. Together, they remind us that the question of whether we are alone in the universe is far from answered, but instead grows richer and more complex with every new discovery. Beyond the scientific implications, these worlds invite us to ponder our place in the cosmos. What does it mean for humanity if other life forms, even microbial ones, exist elsewhere? How might such a revelation transform our understanding of life itself or the way we see our fragile, shared planet? These questions are as vast and infinite as the universe we explore, yet they ignite a shared sense of curiosity, wonder, and unity among us all. As we await future missions and technological advancements to unlock even more secrets of the cosmos, the journey of exploration continues. The answers may elude us for now, but the pursuit itself unites us in a quest to understand the extraordinary universe we call home. If this video has sparked your imagination or inspired you to learn more about the search for alien life, be sure to subscribe to our channel and join our growing community of cosmic explorers. Share your thoughts and tell us which planet or moon fascinated you the most. And if you believe we are on the brink of discovering life beyond Earth, let us know in the comments below. Thank you for watching, and until next time, keep looking up.